Our featured speaker today is Dr. Amy Snover. She is the Assistant Dean for Applied Research and the Director of the Climate Impacts Program at the University of Washington. She is the convening lead author on the third U.S. National Climate Assessment Report, which was issued last week by the Obama administration. Dr. Snover's charge is to connect science and decision-making by linking cutting-edge science with the information and the real needs of resource managers, policymakers, and planners. She works with a broad range of stakeholders to develop science-based climate change planning, and she is the author of a guidebook for regional, local, and national government on how to prepare for climate change. She has a BA in chemistry from Carleton College in Minnesota, and a PhD in analytical environmental chemistry from the UW. Dr. Snover will be interviewed by Steve Scher, senior host of KUOW's Friday News Roundup show, The Week in Review, and co-host of The Record. Steve has worked at the radio station for 28 years, and as he says, spoken with some of the most interesting people in the world. Today is no exception. Please welcome Dr. Snover and Steve Scher to our podium.
Thank you all. It's nice to be here. You guys do great work. I appreciate the work you do. I like the idea of being willing and wise in this conversation and in this issue. So with that in mind, it's good to talk to you again.
Yes, thank you very much, and thank you very much for the invitation to be here today. I really appreciate it.
The Secretary of State came out just this morning talking about climate change and security. And one of the things they said was that what was happening around the world was no longer the possibility of a threat, but it was a threat to national security. That climate change was not just something that added on to our security concerns, but was creating security concerns around the country. But I wanted to just read a little quote from what Senator James Inhofe of Oklahoma said in response to that. He is a critic and a skeptic of climate change. And he said he was critical of the people who spoke about this security issue. There's no one in more pursuit of publicity than a retired military officer. For anyone to say that any type of global warming is anywhere close to the threat that we have with crazy people running around with nuclear weapons shows how desperate they are to get the public to buy this. So there's one aspect of how we approach climate change. We'll talk about another, right? The report that came out, the National Climate Assessment, just to start with that, what made it unique? What was unique about this report?
So the National Climate Assessment came out last week, and it is a report, it's a federal government report written by a team of over 200 authors, of which I was one, that is a congressionally mandated report. In 1990, Congress passed the Global Change Research Act and said every 4 years the government will report on what we understand about climate change. So this is the third report in 2014. If you can do math, it's more than not quite hitting the target. But the aim of the report is really to say, what do we know now? And I had the privilege of serving as one of the co-convening lead authors for the Northwest chapter. We had a team of 8 authors, and we looked across the region at all of the published science and said, what can we say we have seen, and what can we say we expect to see, and what are the consequences of that? So some of the main conclusions of the national assessment at the global level are that we're observing changes across the country that are long-term changes that are completely consistent with what we expect from climate change, and that many of these trends are accelerating over time, and the impacts in different regions are different, but the consequences are significant. And the report really lays out the degree to which I think climate change is an issue for today, and really is something that it would behoove us to have this inform our choices.
Well, you have some slides, so I know you're going to show them to us. The point is that in the past, as we've discussed it and debated it, it was about the future. But with this assessment, the language is a little different, right? It's about, we're here, we're seeing it, these are the results.
Yes, it's a very different look at things, and I think it just adds on to what the global climate science community has been saying over the past several years. The evidence for a changing climate is mounting from the fact that we've seen global average temperature go up, sea level go up, ice retreat around the world. We've seen changes like that in the nation and in the region. So,
before you go there, we also had another report by scientists that came out, was that yesterday, day before yesterday, about the West Antarctic ice sheet and how warmer water, because of the change in the way the system works due to climate change, increased greenhouse gases, is undermining the ice sheet. What's that impact now and in the future, the melting of that ice sheet?
you know, when we talk about global warming, I think there's a lot to talk about, and the report is a really in-depth, detailed look at everything we currently understand to date. But even still, the research keeps emerging on other parts of the issue. And I have to say that reading, I don't know if everyone read this, so the West Antarctic ice sheet is a big concern because of its rapid melting will contribute to significant sea level rise. And in the past, the thought had been that any sort of rapid collapse of this ice sheet would happen over millennia, over hundreds, close to thousands of years. And this new research actually done by folks at University of Washington identified that the melting is speeding up quite a bit. It looks like it's going to happen in the order of 200 years, not 1,000 years, and would lead to significant sea level rise over that period. So the evidence is mounting. When
you say significant, that's because it's a range. The science looks at it and they have a range, not an exact number. So what was the range they were giving for the West Antarctic as it affected around the places around the world? Did it go from 1 feet to 8 feet, depending on the?
I have to say I didn't write the numbers down. I think it was another increase of 2 feet of sea level rise over 100 years, and on top of what was already projected, and then up to 10 for the hundreds of years after that. Right. So it's hard when we talk about it like that. It still doesn't sound like an issue for today when we're talking about impacts that are 100 years off. But what we have to remember is when we're on a trajectory towards that change, we're already on it, seeing impacts as we walk along, as we move along there. And the significant thing about that research was that we've always thought that you could just stop it. And that research shows that it looks like once it starts, it's not going to stop.
Isn't that also what the National Climate Assessment Report basically says about where we'll be by 2030 or 2050 as opposed to 2100? Like we are on a trajectory now for the next 40 years? Yeah, so let's talk a little bit about what we know about what we'd expect to see. And the way we think about how much change we expect in the future is we make different estimates of how much greenhouse gases society is going to emit. This isn't something that we can predict, so the climate science community develops these scenarios that say, maybe in one future we increase energy efficiency a lot and have a lot of green technology and a low population growth, so we don't emit a lot of greenhouse gas emissions. Maybe there's another very potential future, which is we don't do any of that stuff, and we emit quite a lot of greenhouse gas emissions as on the path we're on. And regardless of those two, what the National Assessment makes clear is that we have set change in motion because we've already emitted, as a global society, quite a bit of greenhouse gases. So there is a certain amount of inevitable change and inevitable impacts that we've already built or baked into the system. And so that's the part that our research focuses on in the Climate Impacts Group, is understanding those inevitable impacts and saying which of those matter to who and why, and what could we do about that. On the other side of things,
with the emissions, it's really clear. I think the assessment lays out very nicely that we're making choices right now that have a huge influence on the future in terms of how much warming we're going to see. So maybe, should I show those?
Please, please. So what is it, so in terms of what you have here, what does this say about temperature?
Yeah, so what I wanted to do is I just put together a couple of slides to show you some of the underlying science about what we expect here in the Northwest. And this slide, and I'll read it to you because I know you can't see the numbers, but this shows you historical, the 20th century, what we observed in temperature in the Northwest. And you can see it's a really jaggedy line, right? So we have warm years and cool years. And there is a slight upward tilt. It's gotten warmer at the end of the record. And so if you look over the 20th century for the Northwest, we've seen a warming of a little over 1 degree Fahrenheit. Okay, so that's where we've come from. And the question is, where are we going? So this figure, if you look at this figure, the black jaggedy line at the beginning is the line I just showed you. That's what we'd observed from the end of the 20th century, the 20th century. And then the red and the blue are these alternative scenarios I've told you about, these futures that we are making a choice about right now. The blue one is a lower emission scenario with a lot of energy efficiency and low population growth. And the red one is kind of business as usual, the path we're on right now. So there's a bunch of take-home messages here. There is not a single scenario that shows warming, that does not show warming. There is not a single scenario that shows cooling. The only question is how fast, how much.
You've been thinking about, before you go away from that slide, that those both show warming. The blue line, what kind of reduction in emissions would have to take place for us to follow that blue line? Do you have a sense?
I think it's around an 80% reduction in global emissions, but that's one you shouldn't quote me on. It's a significant impact, a significant reduction. It's around 50 or more percent. And I realize I promised to tell you the numbers because you can't see them. What the difference at the end of the century, so that's a graph that goes out to 2100, and for the blue line, we're about 5 degrees warmer Fahrenheit than we were last century. For the red line, we're closer to 10 degrees warmer.
The science is telling us that we'd have to reduce globally our emissions of greenhouse gases by, this is pretty broad, 40 to 70% by 2050, and be at almost zero emissions by 2100 in order to sort of follow that blue line.
Yeah, you know, there's another scenario that's not mapped on there. The international science community and policy community, you may have heard this, has made some statements over the past several years that one desirable goal was to keep warming under, well, they said 2 degrees Celsius, so 3.6 degrees Fahrenheit. They wanted to keep it under 2 degrees. They decided that was a good target, and above that didn't look good to them, to a lot of people. The scenario that gets us to that keeps us under 2 degrees isn't shown here because it requires really aggressive reductions in greenhouse gas emissions and actually taking CO2 out of the atmosphere.
Yeah. Oh, taking it out as well.
Mm-hmm.
New technology. So so how does this affect us? And you have a slide that sort of starts to show us that.
Yes, I do. So this is one of the ways climate change affects us. Sea level rise and other things are important too, but the fundamental impact pathway for the Northwest is through this warming and its impact on snow. So in the Northwest, we have the highest fraction of what's called warm snow in our watersheds in the country, and warm snow is snow that's around the freezing line, 27 to 32 degrees, right? So we know we don't have very high mountains, we have a lot of that kind of snow. And what happens if it gets warmer? We don't have as much snow. And so here's a map, some maps showing those projections. Again, like all scenarios show warming, all scenarios indicate less snow. And so the top map shows you historical snowpack in terms of water on the ground in the snowpack in April. And the bottom three show you the projected losses for the 2020s of about 30%, the 2040s, 44%, the 2080s of 65%. This is under that sort of, under a moderate emission scenario. And this is something we focus on quite a bit because all scenarios show warming, all scenarios show, on average, loss of snow. We'll still have snowy years, and even worse years than that. But we're marching towards a different future. And this is the impact pathway that underlies a lot of the impacts we talk about that people might think that might hit closer to home, that we can talk about.
So what does that mean if we have less snow? How does that affect our lives?
I want to show you one more, and then we'll jump to the things that matter about fires and health and other things. I want to tell you about how this sort of dramatically transforms the base essential characteristic of our watersheds. So we have many watersheds that are sort of a medium elevation that have winter rains and summer and spring snowmelt. So this is showing from October on the left to September on the right, the amount of water running down one of these types of rivers like the Yakima. So it rains in the winter and you get a bunch of water in the river then. Snow accumulates in the mountains and it melts in the spring, so that's that big peak. And so what does warming do for rivers like this? We're going to have more winter rains because it's raining instead of snowing. We're going to have earlier spring peak and less summer snowmelt. So let's just march through. These are actual projections for the Northwest, for the Yakima, but there's lots of rivers like this. Let's see. The 2020s didn't show up. So here you get the 2020s and 2040s at the same time. We're having more water in the river in the winter and less in the spring. And by the 2080s, we're talking, like I said, this is my basis for my statement, a dramatic shift in the basic characteristic of when water is naturally available in these systems. So now to get to your question, right? So that matters for how we produce hydropower, when we drink water, ecological water availability for fish and for forests, availability for farm. So this is the reason climate change has wide-ranging implications for lots of things that matter here in the Northwest.
Hey, you have produced these tools for policymakers. Have policymakers started to change their questions to you, their activities based on these scenarios? These are not guesses anymore. This is what we are seeing. It's just going to be within this range.
Yes, there is a surprising, perhaps to the general public, a surprising amount of engagement on these issues by a lot of our policymakers and resource managers. So our group has been working here since 1995, doing this science and bringing these messages to decision makers. And in fact, the data that underlie this were funded by Bonneville Power Administration, U.S. Bureau of Reclamation, and U.S. Army Corps of Engineers. They're the major entities that manage the Columbia River system, and they really care when there's going to be water in the river, so they can figure out how and when to make hydropower and how to protect against floods. So they funded the research to develop these scenarios, and they are including them in their long-range planning. I have lots of other examples of entities using this kind of information.
Well, you gave me one when we were on the radio. You talked about how Anacortes built its sewage treatment plant.
Yes, that's a really interesting one. So the city of Anacortes, it's their water supply, their water treatment for their drinking water supply. They recently had to rebuild their plant or build a new plant because of capacity issues. And for them, they're really worried about those increased flows in the wintertime because that brings more sediment down the stream. And if you ever see how much dirt is in that water when it first goes into their plant, you'd be amazed at what comes out clear at the other end. So that's a huge concern for them with the increased flooding risk. And so they used these scenarios first to decide where they put their plant so that they made sure the actual building and the facility was resilient to these kinds of increased floods. And then they also designed it with a bigger capacity because of these projected changes. And that has just been built in the last couple of years.
What's another example of where people are already making some of these adjustments? Olympia is having to deal with the possibility of rising levels along its waterfront, right? Yeah,
Olympia is an interesting example because they've been thinking about this for quite some time. If you know, downtown Olympia is really low lying where the farmers market is. And with sea level rise, that's a vulnerable spot. And so they have been mapping where they expect to see risks from different amounts of sea level rise. And they have really surprising impacts there. So they have urban flooding now, when they have a lot of water in the creeks, when they have a heavy rainfall event, and it's a high tide. And it's not flooding around the edges, it's flooding in the middle. It's coming up the storm drains. They're the opposite of a storm drain. And they know this challenge will be worsened by climate change, and they also know it's a challenge today. So this is a theme, again, that many of the reasons we're concerned about climate change is it exacerbates existing problems. The good news side of that is that we know what to do about these things, right? So they are looking at where they can relocate valuable infrastructure so it's not in harm's way. When they built their city hall, they didn't put the really valuable computing infrastructure on the ground floor of the building. They made it more resilient to flooding. And every year they go back to the city council presenting information about how they're refining their plans for the future.
What affects, wait, did you get them all? Oh, you have one more. Do you have one more slide? Is that the last one?
I think that's the last
one. All
one.
right, good. Because I was thinking about what effect does this have on agriculture in our area? Because west side and east side has slightly different changes that we're facing, right, on Washington State?
Yeah, and agriculture, of course, is an incredibly important sector for this state and this region. And so as part of the national assessment, we were looking at what are the impacts on agriculture. And I think like many actual parts of this climate change story is that there are good news and bad news parts of it. The biggest concern is this irrigation water supply, right? Because we depend on the snow as a natural reservoir to move water from the winter when it arrives to the summer when we need it for fish and farms. And with that loss, that's a problem. So some research says, shows that the risk of junior water rights holders not getting all of their water supply in the Yakima was 14% historically, goes up to 70% annual risk later in the century. But for the other issues that affect agriculture, you're likely to see some increased pests and some increased weeds, but the good news is that the agriculture sector as a whole is thought to be really robust to these changes. They deal with a lot of fluctuations now in weather and climate, and with the global markets. And so that's the story where, with this sort of conscious attention to these issues and some of the benefits climate change might bring to agriculture, such as letting winter wheat grow better because it's warmer, that's the less bad news part of the story.
I was looking at some numbers about frost-free seasons. We're going to have more days that are frost-free in the Northwest. And so do we get different types of fruits growing on the west side? Do they change in their ability to grow longer further north?
I think over time, those are the kinds of adjustments that we would see, right? So spring will come earlier, fall will come later. The length of time when there's no frost risk will increase, so that has implications for what you can grow. Also has implications for what kind of bugs can live as a result, which leads to some of the forest challenges that insect outbreaks, such as mountain pine beetle, are worsened by this warming and are really expected to be one of the dominant ways that the forests here are affected by climate change, in addition to wildfire.
So do we know what that looks like for the forests? Like, what will the forest look like in 40 years or 90 years?
We expect that the major difference we'll notice is that what the scientists call disturbance regimes will have, the risk of forest disturbance will have gone up tremendously. So wildfire risk is exacerbated by warming and by insect and drought. And insects are exacerbated by fire and drought. And these three factors feed on each other. The expectation of this long-term dramatic transformation of the forested landscapes. What trees will grow where well will change over time as well. In the absence of these fires and insects, it would be kind of a slower, gradual change, because trees live for a long time and can tolerate not quite right climate. it's really going to be the impact of these big events, I think, that will be the major driver of change. So there's actually projections, and I'd encourage you, if you're interested in this, to look at the National Assessment webpage. It's really well done, and you can explore these results. But the increased fire risk in the Northwest is projected to double in a couple of decades and quintuple by the end of the century. And again, the risk of really large fires increases. And that's true for the west side as well, but we're still a little better off with our wetter, moister forests.
For example, nationwide, I'm curious about how I know you're a scientist and not a policymaker, so I'm not going to force you into policy questions, but droughts and heat waves of 2011 and 2012 added about $10 billion to farm costs, the climate assessments that are around the country. I talked to an energy expert who talked about an insurance policy, that we see these trends. When people think about insurance, they're not expecting something to happen, but they're hedging their bets. What kind of insurance policies are people asking you about as a scientist when they come with questions? Where do I spend my money? How do I move forward? What kind of questions are you getting?
That's the kind of approach we take for talking a lot about a lot of the aspects of dealing with climate change, because I can lay out these scenarios, but if you remember, underlying all of them was this question about how fast things are going to change that depends on choices society makes. And we can't predict that future, but we can lay out the range of possibilities. And so a reasonable response is to say, how do I deal with that? How do I hedge my bets against that range of responsibilities? So a really good example of that is the Port of Bellingham is doing this huge redevelopment project of the old Georgia Basin site, Georgia Pacific site on Bellingham Bay. And they wanted to also consider sea level rise in this, knowing that they're redeveloping the waterfront, but sea level is projected to increase. But we don't know exactly how fast. And so what did they do? Well, they said, we're going to put our most valuable, most expensive real estate up higher. And we're going to grade the site more than we were planning to before, because we know sea level is going to rise. And we're going to put the stuff that's easy to rebuild, marinas and things that we sort of fix on a regular basis that aren't a huge sunk investment, we're not going to worry about those yet. And we're going to watch how it goes. So it's this, the response really needs to be tuned to the level of investment, the possibility of risk, of loss. And I think these examples actually are part of the good news story of the national assessment. I call it a good news, bad news story. I think that in terms of what we wrote about for the Northwest chapter, I think that, the bad news is this is really sobering, and these are significant impacts, and and a lot of us are concerned because we know that without attention to these impacts, we're not just going to sail through them, right? This is something that will cause difficulty if we don't deal with it. The good news side is that we have a lot of information, and the Northwest is really well situated for that because we have these data and we know what risks we're facing, and we have numbers we can use in planning, and then we have these leaders, right, like Port of Bellingham and City of Olympia and Seattle as well. Lots of examples that show us some of these strategic ways to think through what are the risks and how are we going to cope with them.
You guys have questions, and I want to give the mic up to get your questions, but while you're getting ready to ask questions, just your own research looking at chemistry, what are you seeing in your research that relates back to this larger question? And describe a little bit what you do as a scientist.
Yeah, well, so I will do that while we ask for questions. It turns out I don't do chemistry anymore. So my PhD research was on atmospheric methane, and I was really curious about how much is coming from sources like biomass burning of the rainforests, and how much is removed by bacteria living in the soil. Because methane is one of the strongest greenhouse gases, so it's really important. Now I study these processes of climate change risk assessment and adaptation. And so I'm doing research with coastal practitioners in this state and Oregon and California, asking the question, what would successful adaptation to climate change be? Given that we have this uncertainty, given that you have competing priorities, given that this is causing challenges across risks to infrastructure, risks to ecosystems, risks to people, what are good ways to move forward in that? So that's the kind of research I'm doing now.
First question over here.
Thank you very much, Dr. Snover. That was a very interesting discussion, and I wonder if you could put on the first slide again. Now, given the fact that greenhouse gas emissions, CO2 and methane, have been increasing a great deal over the past decade or 2 decades, how do we square that with the almost straight line increase since the year 1900 there, and I think it goes back to about 1885, which is when we first started having reliable temperatures. There doesn't seem to be an inflection point there at the time that greenhouse gases really started coming up in terms of the industrialization of the West.
So the answer to your question is in part that we are looking here at a very small region of the globe. So when you look at global temperatures, you're not as you don't see as much this variability between individual years, and you can actually see this increase in warming in that sort of since the 1970s. With a slowdown in warming observed more recently. To back up, there's a bunch of factors influencing climate, and one is the amount of greenhouse gases in the atmosphere, and as you rightly say, when they got there, right? So we started with the Industrial Revolution, and we've been ramping up lately. It takes a while for those to add up and have a significant impact on the global climate. At the same time, we have other forces that cause variability. We have volcanic eruptions that happen, we have, and we have natural variability in climate. So what you see in the Northwest is the reality of what it looks like living in one particular place, which is that we're experiencing the combined impacts of the relatively modest global changes to date and the very large variations in our local climate to date. This is Northwest only, these numbers. These are just for Washington, Oregon, Idaho averaged together. So it's a very different picture when you look at global numbers, or even, Northern Hemisphere numbers. The more local you get, the noisier it looks.
Thank you. Given that we want the desirable outcome of the blue line, the lower line, what can we do as individual families? And then if we are in a business, what can we do as a business or a team member or an employee to impact or to contribute the best to this effect?
That's a great question. So I'll try to answer it in a bunch of different ways. One is that the national assessment actually lays out, has a chapter on what science geeks call mitigation, which is emission reduction. It sort of lays out what has been done so far and what some of the options are. I think to really answer that question, you have to say, well, what's the root cause of those changes? And the root cause of those changes is energy use that's dependent on fossil fuels. And in this part of the country, in most of the country, it's about a third from transportation, a third from electricity, and a third from industry in terms of how we are contributing to those emissions. Because we have such clean electricity here, it's transportation is a bigger component. So it's energy use that comes from personal activities and from our economic engine. But I think one of the biggest challenges of climate change is that this is a global problem. And so to make a difference, we need large-scale changes in emissions. And people often say to me, well, what could I do? Because nothing I do matters. I mean, if I could stop all now, nothing would matter. And the answer I have, which is the answer I tell to myself, the only thing that matters is what you do. So I think, that leads to bigger questions about what kind of a leadership or participatory role you as an individual and us as a region and us as a nation want to play.
Next question right here.
You've been talking about global warming. In the Northwest, what effect, if any, do you see this having on the number of sunny days versus cloudy days that we have in the Northwest, and the impact, if any, on the risk of earthquakes? I was curious if there's any relationship.
Thank you for these questions. I'll do the second one first. There is no evidence here, and for a long time people have just dismissed any link between global warming and earthquake risk. As far as I know, there's been no look at this for a specific region, but people are starting to talk about the possibility that it could change earthquake risk. If you think about the fact that with massive redistribution of weight on the Earth's surface, right? We're talking about melting of a lot of ice in the polar regions and on glaciers that is a weight on the crust. And as you redistribute that weight, you redistribute the stresses. I mean, so this is my current understanding is at that level, that there is a sort of plausible reason that they could be linked, but in terms of actually how and with what implication, I personally have no idea, and I'm not sure there's a lot of work on that yet. On the cloudy days versus sunny days, there's some folks who say that we may see cloudier springs along the sort of coastal areas of Washington because of the warmer temperatures and the bigger difference between air and sea. I think the jury's still out on that too. Until recently, we haven't really had the tools to answer that question. We answer that question by running regional climate models. They're like the weather model, but they're run in a climate mode, and we can actually simulate, clouds, winds, and other local factors driven by our topography and the climate to start answering those questions. The other one is sort of hot days, so risk of heat waves definitely goes up, and there's specific numbers for the amount of extra heat days or days over 85 degrees, and these are a concern for, sort of public health and air quality issues, and those are clearly expected to increase under all of these scenarios.
It seems to me that, there's a lot of chatter in our society in opposition to trying to change anything based on the science. A lot of us are convinced in the science. The question would be, since you relate to policymakers and that's your job, is to be between the two, at what point, and we've talked a lot about projections with global warming and how that might impact things, what about projections in terms of society's denial, and at what point we reach a tipping point where we sort of, okay, we understand this is actually happening on a global level, we have to do something. I mean, we were just in Vietnam with a chamber group. They're planning on a future where 40% of the land is underwater in 75 years. It's kind of inconceivable. What are your thoughts on the political side of this?
Well, I think that what you're seeing and sort of the political side and the, well, let me back up. You're not going to be surprised to hear me say that I think that it's a big bummer that this has been stopped in its tracks, action on this, due to polarization of the issue. On the other hand, we're not too surprised, given that that's how a lot of things are faring right now. I think one of the most effective aspects of this paralysis is the well-funded misinformation campaign that is right out of the pages of the playbook of denying the links between smoking and cancer. So the scientific community has come out with, increasingly strong and cohesive and clear statements about what we expect and now what we're seeing. And I think the challenge is to bring this more into public discourse. I mean, this is the other part of my good news story of the national assessment, or the charge it leads us to, which is that, we're making choices right now that affect our future in terms of if we're going to be red or blue, and in terms of are we waking up to the changes that are going to affect which roads flood and where, where it's safe to build or not build. So I argue, and I think the national assessment, but also these data we have, provide a basis for a sustained and engaged conversation about how we want to deal with these issues.
And on that note, thank you very much.
Seattle Rotary Online is made possible in part by a grant from First Choice Health, working with the Washington Health Information Collaborative to use technology to bring better health care to patients throughout the Pacific Northwest. First Choice Health.